So, good morning, everybody. My name is Krystal, and I'm a front-end developer at Obero Shopify. Hope everybody's recovered from the party last night and they can pay attention to what I'm going to say. Okay, so today I want to talk to you guys about some advanced animations that I built with Vue.js. But not to make it super boring, I'm going to start with a little example of a game built with Vue.js, and then I'm going to show some real-life examples of how you can implement the same techniques, basically, of the game in real-world applications. So I actually started working with Vue.js last year, and the first thing that I did was watch this course that you can see the link here. It's from a guy named Maximilian Schwarzmüller, and he created this game on his course, and when I looked at it, because I have a background of working with mobile games, I thought, that's actually really nice. Maybe I can see how further I can push this interface to make it look like an actual game. So this is what I managed to implement in the end. It's basically the same game, but with an interface that is actually closer to what we are familiar with when we are playing games. Okay, so the game sequence of this, so that we can actually start talking about the animation, goes like this, right? So we have this start new game button. When we click on it, we flip the menu to have the attack button and the special attack button. We basically can click on the attack button until the blue bar of mana on the top is completely full. Once that's completely full, we unlock the special attack, and then we can use the special attack. And then every time that we trigger an attack, we're going to check if the health of our character or of our enemy is equal to 0, and if it is, we end the game. Basically, that's it. So in our app.vue file, which is the file that contains all the logic for the game, we basically have two objects, one for our character, which is the player object, and one for the enemy. Both these objects contain similar information. We start with the animation of each character set to idle, and then we have the image path for each one of them, and both of them start with the health at 100. In the case of our character, we have the mana, which is basically that blue bar that I mentioned before, and the enemy doesn't have it. Also, we have a variable to define if the game is running or not, and an animation delay that we are going to use later on. In our methods, we have basically just a bunch of functions that are going to play around with those values that I just showed, and that's how the game works. So in our template, who of you are not familiar with the Pug templating engine? Okay, thank God. So the reason why I decided to use Pug, for those of you who are not familiar with it, is basically just because it has this shorter syntax. It's exactly like HTML, but instead of opening and closing tags, you can understand what elements inside of the other based on the indentation. Okay, so we have then this, inside of the app.vue file, we have two status bar components, which are basically just components that are, because the status bar, we have one for our character and one for the enemy. So they are kind of doing the same thing. So we are just passing down the information that we are passing down that exact object for our player and for the enemy, and then we set the has mana for the enemies to false. After that, we have an environment component that has a slot inside, and inside of that slot, we have two character components that I'm going to show later on. Yeah, each of the character components, once again, receive different information, but they are the same component. So we are using one character component for our player and the other one for the enemy. And then we have the controls, which are basically the ones that we saw on the screen before, which have like the start game button, and then we flip it to the attack, special attack, and give up buttons. Everything starts when you actually click on attack, because this attack method is going to by itself call the increase mana method. The increase mana method is super simple. It's just going to check if the mana is still under 100, and if it is, it's going to increase it by 25. And then we have this update animation method that we can use both for our character and also for the enemy. Basically, it's just a set a timeout. We update the animation immediately to whatever we passed as parameter. On this case, we're immediately changing the animation to be from idle to attacking, and after the set timeout, after that animation delay, we put it back to idle. After that, we are using this calculate damage method, which basically just generates a random number between a minimum and a maximum, and we apply that damage to the enemy health. After that, we check if the game is over, basically just by comparing the number that we have on the health of each one of the characters. And if any of them has died, we update the dialogue that we display in the end of the game to either you won or you lost, and we display we actually update the animation first to be dying and then dead, and then we display that motto that can allow you to start a new game. If the game is not over, we trigger the enemy attack, which basically does the same thing. So if we render just the environment.vue file, you would see something like this on the screen. And this already has a bunch of interesting stuff going on. So you can see that we have some clouds moving on the background, and then we also have some ocean waves moving, and then we also have the ship itself moving. And we have the slots where we put the character inside. So the first thing is that everything is inside of this div with a class background. It's just a div that has 100% of width and height and position relative. The position relative here is important because then we can position everything inside of it by using position absolute. After that, we have this list with the class clouds, and we are using a v-for to basically count from 1 to 10. This means that we can render 10 clouds on the screen. And if you're using something like Sass, you can actually match the loop that you have on your styles to the ones that you have on your template. And then we can make some small adjustments to each one of the clouds so that we have like smaller clouds, bigger clouds, clouds that are more transparent or not, and things that are moving faster or slower, to create this kind of parallax effect that we can see on the background. And to do that, it's basically multiplying some number by the index of that cloud. Because it's a loop, the first time that it runs is going to be, for example, for the animation duration, 1 times 15, and then the second time is going to be 2 times 15, and that's how we can manage to make some clouds moving faster than the others. And then the last thing is that we have this horizontal scroll keyframe animation that are basically just moving them from one side of the screen to the other. Yeah, for the waves on the behind the ship, it's basically the same thing with a different image. And then this one that you can see here in front of the ship is just a div with a background image with this pattern of an ocean wave, and the animation is slightly different. We are, instead of changing the position of the div itself, we are animating the actual background image. And then we apply some transform to push it up into the side a bit and to rotate a little bit. Cool. And then we can talk a little bit about the character file. This file is interesting because it's super simple. It's basically just one div. And we pass down 2 strings, one for the character name and the other one for the animation that we want to play. And then we basically use the character name to fetch the correct image path. And then with this image path, we create the inline style of the div, which is basically applying the background image for the correct character based on the name. And then the animation name is always going to be updated with that update animation method that we saw before. Yeah, so this character component actually uses sprite animations, which is basically just this really big image with a transparent background. And then we have each row of this image is going to be a different animation sequence, and they are all going to have 10 steps. So this means that for the animation itself, the only thing that is going to change is the initial background position and the final background position. So in this case, for example, we have the keyframe animation for the idle animation. So it starts at 0, 0, and it finishes at approximately 5,000, which is the total size of that image. So if we applied only the animation that I just showed, you'd see something like this, which is basically the image moving slowly from one side to the other. But to actually make it play like a movie, we need to change the animation timing function. And as mentioned before, each row of the image is a different animation sequence, and each row has 10 steps. So that's why we, on the animation timing function, define it to have 10 steps. Yeah. And then the only thing that is different between our character and the enemy is that for the enemy div, we flip it around so that one is facing the other. Cool. And now we have transition tags. This is actually a really cool feature that just comes by default with Vue. And it basically allows you to apply automatically CSS classes, or you can pass the element to JavaScript hooks so that you can animate it. And you have access to these events automatically for whatever element is being inserted or removed from the DOM. So in this case, you can see that inside of the transition tag, I actually have a VIF and a VElse that are changing what buttons I'm going to display on the screen, either to start a new game or when the game is running, the actual buttons to attack and interact with the game. So these are the events that I mentioned before, and you can access them with JavaScript hooks or with CSS classes. On this specific case, I'm just using CSS classes to make the animation. So the way that it works is that we define a name for the transition tag. On this case, I named the transition tag bounce. And then I just have to use CSS classes with the naming convention defined on the docs, which is basically the name of the transition itself, bounce, and then the event that I want that class to be attached to the DOM. So I have bounce enter active and bounce leave active, which are basically the same thing, but I'm reversing the animation when the element is leaving the DOM. And this is the bounce animation, nothing special. I'm just translating it and changing the scale so that it pops a bit and then goes out of the screen. Yeah, and this is a slow motion video of how these classes get attached to the DOM and then removed from the DOM. So you can see that when I click on the button there, the actual div that contains the class controls is attaching the bounce enter active and bounce leave active to the div. That's what happens, but super fast. Yeah, so then this is the game sequence. Once again, we clicked on the start game button, and then we access these buttons that are inside of the transition tag. And then we can just attack until the blue bar of mana is completely full. Once it is, we can unlock the special attack. And then we can just keep attacking until one of them has died. Once that happens, we display that dialogue, and then we can start the game sequence again. Cool. So that was it from my fun example. Now we can talk about some real-life examples based on this. So a little bit more on the transition tag. As I mentioned before, I think that this is a really cool feature that Vue has. And if you're using something like VIE-ROUTER to define the routes of your application, you can actually make transitions with the transition tags from one page to the other. So as a really simple example, we can, for example, fade between one page and the other page. So in this example, we are actually, you can see that the URL is changing, so we are changing routes. And we are applying this fade transition between the pages. To do that is super simple. The only thing that you have to do is place the router view inside of the transition tag. And then the same rules of naming and following the naming convention apply here. Yeah, so in this case, it's just a transition that is basically changing the opacity, and it doesn't have any CSS animation attached to it. And another thing that is happening there is that I'm using the router link that is also that also comes with VIE-ROUTER to put a custom active class to my buttons. So this means that when the button is not active, I'm going to have a menu item class attached to it, and when it is active, I'm going to have a menu item active class. And so that I have that little line that is appearing under the menu buttons, that's actually a pseudo element before, and when the element, when the item in the menu is not active, it's going to have a 0 of width, and when it is active, I switch the width to 100%. So because it has the transition applied to it, it's actually going to have that little animation of the line appearing under the menu item. Yeah, and the same way that we have, that we can use the transition tag to transition between one page and the other, we can actually do the same thing for nested routes. And on this example, I'm actually dynamically changing what the animation name is going to be based on the route itself. That's why you can see that when we are going up, the animation slides down, and when we are going the other way around, the animation slides up. Yes, so yeah, here you can see that the way that we can do that is basically by using a vbind, which are the two dots there, for the name of the animation, and then we are passing the transition name, which is a variable that we save inside of our data object. And then we are using the before route update, which is a navigation guard that we can access because we're using VIE-ROUTER. And by using this navigation guard, we have access to the to, from, and next, which are basically the current route, the route that you're going, and then you actually go to the route after you perform some action with it. So in this case, just a simple example, I'm just checking if the parameter on the URL, the number, basically the number of the child there, is bigger or smaller than the next one, and then I choose to either say that the animation name is going to be slide down or slide up. This is a really simple example, but I just wanted to show you how you can actually decide what animation you're going to use based on the route that you're going and the route that you're currently at. And for the transition here, it's nothing special at all. It's just a translate, and the only difference between one and the other is that for one, I'm using translate 300 pixels, and for the other one, minus 300 pixels. In the same way that we have the transition tags for elements that are being inserted or removed from the DOM, we actually have this special tag for group transitions, which is basically when you want to reorder items on the list, or when you want to insert new items on that list, or remove items from that list. It's basically the same concept, but it works a bit differently. So this is the code for that example that you can see there. And basically what's happening is that instead of passing a name for the transition tag, we actually use this transition group tag. And the transition itself is going to be fetched from whatever we define on the class of the items of that list. So in this case, every list item has this class called item. And then you can see that we have defined on the transition that it's going to be applied to the transform. It's going to last 1 second. And we're using a cubic Bezier timing function there. And then it automatically actually creates the animation for me. I didn't have to do anything manually. Okay, another interesting concept that I wanted to show you is that you can actually wrap these kinds of animations inside of a component so that you can actually reuse it afterwards. So if you have a component that you know you're going to need to reuse, for example, like this floating button menu, which is a really common pattern that we have, for example, in material design, you can actually create a component that is just going to receive an array with the elements that it has to render, and the animation part is going to be handled by the component. So the way that it works is that basically we have this menu is visible variable, and the menu is visible variable is being toggled every time that we click on the button. So it starts at false, and then when you click on it, it goes to true, and the other way around. And we use this variable to actually display the overlay that we can see behind the main menu, and also to calculate the position of each one of these child buttons once the menu is open. So this is the child buttons array. Basically, it has every information that we need to actually render it on the screen. So we have a label, we have a link, and we have an icon. And that's everything that we need to actually render the child buttons. So we are using a v-for to actually loop through each one of those items of that array. And then we have this calculate button style method, which basically receives an index because we are using a v-for there to loop through the items on the list. And then based on the index, we actually calculate the button styles, which is exactly the same technique that I showed before for the clouds on that environment background, for example. So here we have the bottom property, for example. The first thing that we do is that we check if the menu is visible or not. And if it is not visible and the buttons should be hidden, we set the bottom property to 0 pixels. And if it is visible, then we calculate it based on the index. So basically, we have the first time for the first button is going to be 1.3 times 50 equals 65, and then for the second one, 2.3 times 50 equals 115. And this guarantees that we are always going to have 50 pixels distance between one button and the next one, so that we don't have to do any calculation for this animation manually. And this also means that we can pass whatever number of child buttons to this component, and the animation is going to be calculated automatically. The same thing for the transition delay, because we want the animation to actually be staggered. So we want the first button to appear really quick, and then the second one is going to be after the first one, and so on. And the last thing is that we scale down the size of the button a bit when the menu is not visible. So this is a really, really long menu. Don't do that. But I just wanted to show you what I meant when I say that you don't have to worry about the amount of buttons that this component is going to render. You just pass down the array with the information that you need to render on the screen, and then it automatically calculates everything for you. Another example, you can have this collapsible content component for whatever information you want to display a little bit, and then you click on the button to read more, and you display the full content. So once again, we have one variable that defines everything, which is this show variable, and when I click on the button, we change it from false to true, and we use this variable to actually change the classes of the component. So based on the show variable, we are going to define if the hidden content class is open or is collapsed. The same thing for the toggle button class, if it is open or if it is collapsed. And also for the read more text itself to be either show less or show more. And if you pay attention to the button itself, you can see that it has this little animation that goes from a minus to a plus. And the way to do that is basically that we have two pseudo elements before and after with an empty content and 10 pixels of width and 2 pixels of height. This means that it's like a really tiny line, and when it's supposed to form a minus, both lines are on top of each other, and then when we want to form a plus, we attach the isCollapsed modifier to the class, and then we just rotate them so that it becomes a plus instead of a minus. Yeah, so a little bit of data visualization now. On this example here, I've built a really simple chart with SVG, and I'm using Greensock's twin light library to actually make the animation from one data set to the other. So on the template section, you will notice that we are actually looping through the lines array. So let me show you how it is built. Yeah, the lines array actually is going to contain from and to x and y coordinates, and its index and it's also the data points itself, which are basically the numbers that we are displaying on the chart. So if you imagine that we are creating this chart based on a grid that is of 10 by 10 squares, multiplying and summing the number of the index of that item in the array by 10 is going to guarantee that we are always going to have a 10 pixels distance from one data point to the previous one horizontally, which is exactly the same thing that we did with the floating button menu and also with the clouds. We are basically multiplying a number by the index to define its position. Yeah, as this is just an example, I'm generating some random numbers just to fill the chart, but of course you could plug in some real data set in there. So basically what's interesting here is that the new set method actually saves the current data point in a previous points variable and the new points in the new points variable. So this allows us to use the Greensock library to actually animate each number. So what's happening here is that I'm actually animating one number, each one of the numbers in an array until it reaches the next one. So in this example, you can see that it actually starts at 25 and it goes up to 45. But if you look at the numbers being console logged, you can see that we don't go linearly from one number to the next one. We actually go up to 46, and then we go down to 40 again. These numbers that are being console logged are exactly the same numbers that you can see on the chart itself. I just wanted to show to you guys how it happens that it goes up and then it goes down again. And this is because of the timing function that we are using here, which is an elastic timing function. That's why on the chart, it kind of has this elastic effect, like if it is bouncing a bit before it actually reaches the end of the animation. Another cool thing that you can do is integrate Canvas into your Vue.js application. And on this example, we basically have a lot of bubbles that are bouncing off the edges of the screen. And when they are close to the mouse, we change their color. Yeah, we change their color and we increase their size. And the way that it works is that we have this canvas tag. And the canvas tag has this on-mouse move event that we are basically updating the mouse position every time that we move the mouse on the canvas. And then we also have a reference to this canvas so that we can access it from the script section afterwards. Yeah, the update mouse position function basically just updates the mouse position. It basically saves the X and Y coordinates of where your mouse is so that you can easily access it afterwards. And the mouse object itself is saved inside of the data object. And we also have this empty circles array that we are going to fill soon. So in order to actually create all of these circles that we can see on the screen, we are using the mounted lifecycle hook of the JavaScript, the Vue.js component. And we then access the canvas tag with the ref that we created. And the first thing that we do is basically set the width and the height of the canvas component to whatever the width and the height of our window is so that it's full screen. And then we have a for loop that basically accesses the number of circles, which in this case is basically just a prop so that we could use it to render 10 or 15 circles. And then inside of this for loop, we actually have this random number function that we're going to use several times. First to generate a radius of the circle, and then we also multiply it by 2 to save the diameter of that circle. And then we create the circle object. The circle object is going to contain the radius of the circle and also xy coordinates, and this dx and dy variables, which are basically just the velocity. -1 for the maximum, yeah. So positive numbers are for positive velocity. It means that it's going forward, and when we invert the number, it's going backwards. That's why we have from -1, from 1, for the velocity of the circles, and dx and dy because it's horizontal and vertical. And the only thing that is different here is that for the x and y coordinates of the circle itself, the random number has to be from the diameter of the circle to a maximum of, on the horizontal line, to the width of the circle minus the diameter of the circle. This is going to prevent us from creating circles that are outside of the canvas. Yeah, and then the color, we are just passing a main color that we receive by props. And then we actually push the circle to the circles array by using this create circle constructor. Yeah, the number of circles that we receive by props, and then just a random number generator. And this is the actual constructor. Yeah, so the constructor for the create circle actually receives the circle object, which was the one that we just created 5 seconds ago. And then we have the canvas context, which is basically the canvas tag that we created on the template. And lastly, we have the mouse object that is all the time being updated when we move the mouse on the screen. Yeah, the one thing that is important to notice here is that when we are creating the fill style for each one of these circles, we are actually rotating it based on the radius. So that's why when we increase the size of the bubble, we are actually changing its color as well, from the greenish tone that it originally is to the more blue tone that it reaches when it interacts with the mouse. Yeah, so then we have this draw method, which basically draws the circle on the screen. And then we have the update method. The update method, the first two ifs are basically checking if the circle is still inside of the canvas, because we want them to bounce off the edges of the screen. So if it is on the edge of the screen, what we do is that we invert the velocity, because as I mentioned before, positive numbers are moving forward and negative numbers are moving backwards. And then on the update function itself, we actually call the interact with mouse method. And the interact with mouse method does something similar, but it just checks to see if that bubble is close to the mouse, around the 15 pixels of radius that we have around the mouse. And if it is, we are going to increase it by 1. And if it is not, we are going to reduce it by 1. So that it's always like reaching a maximum radius that we can define and going back to a minimum radius, which was the original size of that bubble. Yeah, and in the end of our mounted, you can actually see that we call this animate method, and this method is the method that makes it all happen. So the animate method actually first calls the request animation frame, passing itself as a callback to be invoked before the next repaint. We then clear the whole canvas, and then we call the update method of each one of the circles in our array. So it looks like a movie, but it's not. We're actually erasing everything at each frame and painting it again on the next position. Yes, so once again, we have a lot of bubbles, and they are bouncing off the edges of the screen. Once the bubbles are close to our mouse, we are changing their size and their color. And that's it, I guess. Yeah, that's it. So do you have any questions before clapping? Questions? I'm not getting out of here until I have at least one question. Come on. No?
How do you do your slides? They are amazing.
Keynote and a lot of videos of my screen. Okay, so that's all, folks. And the slides and the examples are on my GitHub, but you can also ping me on Twitter if you have any questions afterwards that you are ashamed of asking now. And I'm also going to be around, so please come talk to me. Thank you.